Yeah. Good evening, everyone. Can you hear my voice?
Yes, sir.
Yes. Okay. So, in the welcome. First of all, welcome to this live session on 8/4/2026. So, as per your request from the previous live session, okay. So, we'll be solving only the problems on the root locus in this live session. So, we'll solve 2 to 3 problems. If you are having any doubts on, in the steps, you can ask me. Okay, so let's start the first one. Okay, so let's say we have so g of s equal to s plus 2 s plus 4 by s multiplied s plus 1 s plus 5 s plus 10. Okay, so let's say we have this plant transfer function. So consider we are using the proportional controller. Okay, so the question is to draw the root locus. Okay, draw the root locus for the proportional controller. Okay, so basically, how do we draw the root locus? First, we find the uh, this is g of s. Okay, so then we have this proportional controller. Then we have output phi. Then we have a reference input. We have summing point here. So then we have this feedback. Okay, so assume that feedback is unity. Okay, so this is plus minus. So now if you find the with P controller, proportional controller, closed loop transfer function. Okay, so GC of S. Okay, so which is nothing but kg by 1 plus kg. In fact, that is kgh by 1 plus kgh. But here we have considered the unity feedback. Okay, so that can be written as k multiplied to, okay, let me copy this. So this is g. Okay, so this is kz. So similarly, we have another thing. Okay, so that will be like kg by 1 plus kg. Okay, so this is your uh, a closed loop transfer function. Okay, what is our first step basically? Is this step clear? If you are having any doubts, you can ask me. Okay, so first we have found the closed loop transfer function. Okay, so next, so we are starting with the root locus steps. So let's say step one. Okay, so what is step one? First we write the form in the Evans form. Okay, so closed loop transfer function, that is nothing but GC of S is written as G1 of S divided by 1 plus K G2 of S. Now compare this one, this expression with this expression. Okay, so how do we find? So we find that this entire thing is your G1 and this is your G2. This is G1 of S and this is G2 of S. Am I correct? So now we can write that as, okay, so this part is your G2 of S. Is there any doubt about this events form? Okay, so basically what is this G2 of S? This is nothing but your the open loop transfer function. Okay, we will draw the root locus for this open loop transfer function. So what are the open loop poles here? What are the open loop poles? So P1 is equal to 0, P2 is equal to -1, P3 is equal to -5. So P4 is equal to -10. Am I correct? Then open loop zeros are, so Z1 is equal to -2, Z2 equal to -4. Okay. So ultimately, what do we have? We have number of poles, they are 4. Okay. Number of zeros, 2. Is this step clear? Any doubt? Any doubts?
No, sir.
Yeah. So that is step one, writing that in the events form. Okay. Next. So next is step two. Okay. Step two, what we do? So we have to find the starting and ending points of the root locus. Starting and ending point of the root locus. Here we could see that n is equal to 4 and m is equal to 2. So out of, we found that number of poles n is equal to 4 and number of zeros m is equal to 2. Okay, so what are the starting points here? What does it mean? So basically this means that two poles, okay, go to, two poles goes to two open loop zeros, correct? Two open loop zeros. Okay, so two
Sir,
open loop, yes.
uh, we have to find asymptotes. That is 4 minus 2, then equal to 2. Then we will tell that two poles goes to two open loop
Both are
zeros.
same, both are same thing.
Oh,
Because we are
okay.
first checking how many zeros we have. So we are
Okay.
taking number of that many number of poles will go to those. Both are same. Okay. The
Okay.
remaining two poles out of four poles, they go to infinity. Okay. So
Then,
that is
sir,
our
what
yes.
if there is one zero?
Sorry.
If there is zeros is one, number
Zeros
of
is
zeros
one
is one.
one zero. One pole will go to that zero. Then three poles will go to the infinity.
Okay.
Okay. If
Okay.
there are no zeros, all poles will go to infinity.
Okay, sir.
Okay,
Okay.
first we decide how many poles go towards zeros, then we decide how many will go to infinity.
Okay, sir.
Okay, so now what are the starting points basically here? Starting points are nothing but the open loop poles. In the second step, that is our conclusion. So the ending points is nothing but the open loop zeros and this infinity part. So ending points are open loop zeros, two poles are going there and two are going to infinity. So this is the conclusion. Okay. So that is our second step. Next, third step. So step three. Okay. So what do we do is we'll find root locus on the real axis. Root locus on the real axis. Okay. So to find the root locus on the real axis, first locate the poles and zeros on the S plane. Okay, so this is real of S, this is imaginary of S. Okay, so where we have the poles, if you see the poles information 0, -1, -5, -10, and zeros are -2, -4. Okay, so let us locate them. So poles are at 0, -1, -5, and somewhere here -10. Okay, zeros are at, so zeros are at -2 and then -4, correct? So -4. Okay, I think this should be clear. Is there any doubt in this? No. Okay, so now in this real axis segment means I told you already this step is important. Okay, so you start your journey from this point and assuming that you are traveling in this direction. Okay, always when you travel in this direction, always check at your right side. Okay, suppose if you are here, okay, if you are here, so how many poles you have, how many poles and zeros put together you have on the right side? That is zero, am I correct?
Yes, sir.
Yes, so that is not, this part is not part of the root locus because that is zero. Okay, done. So now you are here, how many poles and zeros? Still again zero. So till this point is not part of the root locus. Okay, now let us say you are here now. Okay. How many poles and zeros you have? One pole. Correct.
Yes, sir.
So it means that this is part of the root locus. Okay. So now let us say you are traveling. You are traveling till this point. That property holds same. Am I correct?
Yes,
So
sir.
yes. So it means that till this point it is part of root locus. Okay. Now if you are here, okay, how many poles and zeros you have? Two poles on your right. Okay, two poles
Sure.
on your right. Yes, yes.
So minus one will be inclusive or exclusive?
It is inclusive only.
Oh, sure. Thank you.
Yeah. So I mean, it's not like inclusive. You are standing at minus one. Okay. So always minus one is part of root locus because you are starting there. Okay. So now you are standing here. Okay. At this point, if you look at right side, how many you have? How many you have? Two poles, correct?
Yeah, even number.
Yes,
So
sir.
that is even number.
Yes.
Since that is even number, okay, this part is not part of root locus. Is that clear? And that is true for this entire part. Am I clear? This entire part is not a root locus. Why? Because wherever if you stand here from this point to this point, if you look at right side, you'll have two poles only. Is that correct? So that
Yes,
is
sir.
even. That is even number. So that's why this is not part of root locus. Okay. Now you have crossed this zero at minus two, and if you are here, now you check. You are somewhere here. If you check how many you have, so
Then
two
3.
poles spell two poles plus one zero. That is odd number. Okay. Then this is part of root locus. So that is true even if you are standing anywhere between on this point. Okay. So now again, if you cast that and stand here, what is your conclusion? Again, you have four number if you stand here. Okay. So that is not a this is not part of the root locus. Okay. Yeah. Just a minute. Yeah. Sorry. Yeah. So now if you are standing here at this location, okay. So again, if you look at the right side, you have four, two poles and two zeros. Hence, this is not part of the root locus. Okay. Now, if you stand here anywhere on this line, okay, anywhere on this strip between these 2 points, again, that will be five number. Am I correct? So that will be
Yes,
part
sir.
of root locus. Correct. So it's like that. Now, if you stand here somewhere on the right side, you have total six numbers. Correct. Then that will be not part of the root locus. Am I correct? Okay.
Yes, sir.
Now, yeah. So now you can see if you're having any doubt, you can ask me clearly on this. Sorry, I'm removing these points. If you're having any doubt, you can ask me because these are no more needed for me. So only these red strips are part of root locus. Any doubt in this? Only the red lines are part of root locus. This one, and this one. So that we call that is as the root locus on the real axis. Any queries? If you're having any queries, please ask me in this.
No, sir.
Yeah. Okay, so now we'll find the asymptotes. So that is step 4. So step 4, I'm writing here only. First one is asymptote. Oh, sorry. Okay, so asymptote. So equation is ID. So which is nothing but 180 degree plus alpha 360 divided by n minus m. Okay, so here alpha will vary from 0, 1, 2, etc. n minus m minus 1. Okay, in this case 0, in this case, so 4 minus 2 minus 1. What is it? 1. Correct. So it means that alpha is up to 0 and 1. Correct. So now in this case, when you substitute, this is pi alpha. Okay. So you'll have pi 0 and you have pi 1. When you substitute alpha is equal to 0, you'll get 90 degrees. When you substitute alpha is equal to 1, you'll get 270 degrees. Is this step clear? Okay. Then you have B is so asymptotic centroid. Asymptotic centroid. Okay, so that equation is the sigma is equal to sigma pi minus sigma zi, summation of poles minus summation of zeros. Okay, so that is nothing but summation of poles is this one, summation of zeros is this one by the 4 minus 2. Okay, you'll get minus 5. Is this step also clear? Any doubt? Any doubt? So
Yeah.
now you can see minus 5 is the minus 5 is our centroid. Okay, so this is the centroid. Let me put it in a different color. Yeah, so minus 5 is the centroid. Okay, so with respect to that, you have to draw these 90 degrees and 270. Okay, 90 degrees means this one thing, one asymptote. This is 90. Okay, then 270 means this one. Is there any doubt in this? It goes like this. Any query? Two asymptotes.
So we have to exclude -5.
Sorry. No, no, I'm sorry. Sorry. I've drawn it -4. It has to be at -5. Exactly. Yeah. This one. This is the angle and this is the angle. Is this clear? Exactly at -5, not to exclude. Okay. The centroid. The centroid and that -5 pole both are at the same location. Clear?
Yes, sir.
Yeah. So that is our step 4. Okay. Next step 5 is to find the angle of departures and angle of arrivals. Okay. So for that purpose, I'll okay go to next page. So step 5.
Excuse me, sir.
Yeah.
Yeah. So can you slide? Here.
Mm,
Is it a coincidence we have get the centroid at -5, which is a pole, or
mm. No, it
is
is
it a
just a
coincidence?
coincidence. It is just a coincidence.
It will the centroid will appear
Not
in
necessarily.
any
Not
on the
necessarily. Not necessarily. It can be on anywhere on the this
number
thing.
line.
Not
Okay.
necessarily a pole or zero.
Thank you, sir.
Okay, so we can get somewhere in the middle of -5 to -10 also. Okay, so now step 5 is finding angle of departures and angle of arrivals. So angle of departures we will find with respect to the poles. Angle of arrivals we will find with respect to the zeros. Okay, so first we'll check the first one, angle of departures. Okay, so the let me draw the poles and zeros once again. Okay, so we have pole set to 0. Okay, -1. Okay, and 0 at -2. Okay, so this is 0, -1, -2, and 0 at -4, pole at -5, and one more pole at -10. Okay, this is what we have. Okay, now, so the angle of departure equation is sigma pk, sorry, p zk minus sigma theta, I'm sorry, this has to be theta, sigma theta p, sigma theta zk minus sigma theta pj, where j is not equal to I, okay, minus theta di equal to 180 degrees. Okay, what this equation
Sir,
basically says is, yes,
uh, can we write direct, that is theta di equal to 180 degree
that is also correct.
minus
That is also correct.
minus
Okay,
summation of pi plus summation of z.
yeah, that is also correct. Ultimately, here, what we are trying to finding is this term. Okay.
In this, sir, I have one question regarding this equation. If
Ah,
we arrange this equation, then from here we can write, we are saying that phi di is theta di is equal to summation of theta zk minus summation of theta pj
mm,
minus 180 degree equal to
that
theta
is
di.
correct. That is correct.
This
That
is
is
also
correct.
correct.
That is also correct. Okay. So now here you see now. Okay. So here we are doing calculation for first one as calculate theta d1. That means what? With respect to the pole at 0. Okay. Here first pole means this one. Okay. First pole means this one. Okay. With respect to, for that, we are finding the angle of departure. That means that if the root locus started at this pole, okay, with how much angle it is departuring or leaving that pole, because it has 360-degree view. So out of 360-degree, with what angle it is leaving? Okay, let us see that. Okay, so now I can write this equation like this. Okay, how many zeros we have? So we have two zeros. So that's what this sum says. Minus how many poles we have except that pole at 0. So theta P2 plus theta P3 plus theta P4. Okay. Minus theta D1 equal to 180. Is this step clear? We are interested to find theta D1. Okay. So now, okay. So basically what we are trying to do here is, uh, let me tell you that simple again. Okay. So if this is your x-axis, basically what we are trying to doing is measuring the angle like this. If this is your vector, okay, we move the vector in the anti-clockwise direction. Okay, so in this direction, that is positive angle. Okay, this one is 90. If I move like this one is 180, and this one is 270. This one is either 0 or 360. Is this clear? Okay, so now what we are trying to doing here is we are trying to checking, okay, all these angles, they are the vectors if you draw from that pole or 0 to this P1. Okay, so let me show you that. Okay, first theta Z1. What is theta Z1 is? Theta Z1, if you draw a vector from first pole, first 0 to P1. Okay, theta Z2 from here, this one. Okay, then theta P2. Okay, this one. Then theta P3, this one. P4, this one. Is this clear? In fact, all these lines you have to draw on this line. Okay, but to visibility, I have drawn like this. Is this clear? Okay, now you can compare all these vectors, all these arrow marked lines with these arrow marked lines. To which one it is matching? They're all matching with what?
Sir, which line
They,
you have to?
yes, yes. All these lines, okay, they are matching with four of these lines. Which one? To which line they are matching? This line. Am I correct?
Yes, sir.
So what is that? What is that line? What is that arrow marked line doing with this horizontal axis? Zero.
0 degree, sir.
Yes, exactly. So all these are zeros. So theta d1 is what? 180 degrees. Is this step clear? What do you mean by 180 degree here? Can anyone tell me? No, in this. What do you mean by 180?
Sir, theta d1 will be minus 180 degree, na?
Sorry. Theta d1 is minus 180. Yes, correct. Thank you. So minus 180 degrees. Okay. So now here, uh, as I said, this is anti-clockwise, that is positive. Okay. Uh, then if you go in this direction, the angles will be counted as negative, correct? So this will be minus 90. This will be what? Minus 180. Am I correct?
Yes, sir. Yes, sir.
Minus 180 plus 180 both are same. Okay. Now here this is minus 180. What does this mean? Can anyone tell me?
Then pole will go downwards, clockwise.
No,
That 0.
That
no,
P1 pole will be at 0 or else in minus infinity.
not exactly. So basically, angle of departure means the root locus will start at the pole. That means it will start at this pole. Okay. It will departure with this angle. What is that angle? Minus 180 means this one. Am I correct? Yes or no?
Sir,
It will
where are
go
you
via
marking?
third quadrant.
Where are you marking? Minus 180.
This one. Let me show you once again clearly. So that will be like, can you see this? This angle, correct?
Yes, sir. Yes, sir.
That is minus 180. It means that in final root locus, okay, this pole has to start with this angle. Only starting point. Is this point clear?
Yes, sir. Clear.
After starting with 180, it may take any diversion, but starting should be 180. That is minus 180. Okay. Any doubt? Any doubt in this?
No, sir.
Yes. Okay. Next. So that is with pole 1. Next, let us do with calculation of theta d2. It means pole 2. What is P2 here? P2 will be minus 2. So again, draw that. Okay. So, okay. So where we have is, so here one, we have pole, minus 1, 1 pole, 0, 0, pole, and pole, correct? So this is 0, minus 1, minus 2, minus 4, minus 5, minus 10. Am I correct? Now what we are looking is this one, correct? Okay. So now basically again what we have to do is same thing. We have to write extension of this equation. How does it looks like? Here I will become 2. Okay. Now that equation would be like this. Okay. So angles from the two zeros, angles from the two zeros minus angles from the remaining three poles. Not like that. P1 plus theta P3. plus theta P4 minus theta D2 equal to 180. Is this clear? Any doubts? Okay, now what is your P2? This is your P2. Okay, now what are all these angles? Theta Z1, theta Z2, theta P1, theta P3, theta P4. They are like this. So from theta Z1 is nothing but this one. Theta Z2 is nothing but this one. Okay,
Sir, it
theta
would be
P1,
theta P2 plus theta
this
P1
one.
plus theta.
Theta P3 is this one. Theta P4 is this one. Is this clear?
Why is that theta P1 is there?
Theta P1 is angle from here to here.
Okay, so
Okay,
we do
simply
not
draw
have
the,
to
no, no,
consider that P2.
no, no, simply draw the, from that pole to P2, an arrow mark. Okay, previously what we have done, this is your P1. From every other pole to 0, we draw the arrow mark and we have compared with this. Correct? Yes or no?
Yes, yes.
Okay. So now same thing. Now tell me these values. These are same. Yes or no? This will be 180. Will you agree? And again, these are zeros.
Yes, sir.
Okay. So now in this case, theta D2 is what? Minus 360. Okay. So minus 360 means what? Minus 360 means what? From here,
Then it will be
this is 0. Sorry. That is 0. This is minus 90, minus 180, minus 270, minus 360. So same thing. Correct? But look at that direction. It goes in this direction. Am I correct? Okay. So departure of P2 in which direction? This direction. Is this clear?
yes, sir.
And departure of P1 is in this direction. Correct? I'll write it here. In this direction. Am I correct? Both are in the opposite directions.
Yes,
Any
sir.
doubt here? Okay. Next, similarly, let's do for the next one also. You'll understand it. So calculate theta D3. That is for P3 is equal to minus 5. Okay, again, so 0, 0, 1, 1. So 0, minus 1, minus 2, minus 4, minus 5, minus 10. Okay, so what is your point here? Your point is this one. Okay, so what are your vectors in this case? Okay, so first write down the same thing, theta z1 plus theta z2 minus theta P1, theta P2 plus theta P4 minus theta D3 equal to 180. Is this clear? Okay.
Yes, sir.
So now draw the vectors. Okay. From theta Z1, this is the vector. Theta Z2, this is the vector. Okay. Theta P1, this is the vector. Theta P2, this is the vector. Theta P4, this is the vector. Correct? You now compare the equations and get the values. 0 plus 0 minus 180 plus 180 plus 0 minus theta D3 equal to 180. So what is the theta D3 is minus 540. Okay, minus 540 means what? Okay, so
Sir,
90 minus 90 minus 180 minus 270 minus 360. Okay, how much this will be? Again,
sir,
one more round. Yes.
that theta z1 plus theta z2 is 0, 0. Both are 0.
Sorry. Theta Z1,
Is 0,
Min-
sir.
theta Z1 and theta Z2. Uh, just a minute. Let me draw it. Okay. So this is the uh, 0. Okay. 90, 180. Now you can compare it. So theta Z1 and theta Z2. These two only, no? This one and this one, correct? Oh, yeah.
Yes, sir.
That should be 180. Am I correct?
Yes, sir.
Yeah. That should be 180. Then theta P1 is 180, correct?
Yes, sir.
Theta P2 is also 180.
Only sir theta P4 is 0.
Theta P4 is 0. Now, what is the summation? Is it one thing gets cancelled? I think it is 540 only. No? What is the value? This one gets cancelled. This one. Is it 180 only?
Yes, sir.
Yes,
Uh,
sir.
Minus
Minus
180.
1 is
minus 180. Okay. Yeah. Minus 180. So now again. So this one minus 180 means same direction.
Same,
Correct?
sir. Minus 180 and 180.
Yeah. Is this step clear? Now theta D4. I'm not doing calculations. I'm directly saying that this is minus 720. Minus 720 means what? Zero direction only. Correct? I'm not doing that. So that will be opposite. Will you agree?
Yes, sir.
Yeah. So now departure angles are done. Okay. So let me do for the arrival angle. So angle of arrival. Angle of arrivals. Okay. So this equation will be sigma theta zk. So k is not equal to I minus sigma pj. Okay. Plus theta ai equal to 180. Okay. So this is the angle we are interested to find. Okay. So we have two poles. First, let us calculate theta a1 that is related to the 0 of minus 2. Okay. Again, draw that. Okay. So this is 0, minus 1, minus 2, minus 4, uh, minus 5, minus 10. Okay. What we are looking is this. Sorry, this also has to be 0. Okay, what we are looking here is this one, correct? So how does this equation gets to theta z2? Okay, because the I k is not equal to I. Okay, then we have only the other 0 left out. Theta p1, theta p2, theta p3 plus theta p4 plus theta a1 equal to 180 degrees. Correct? Now similarly draw the vectors. Okay, so first one is from here, this is one vector. Okay, this is one, sorry, this is one vector, this is one vector, and then this is another vector, and then from here to another vector. Clear? So now check that directly we are writing. First one is 0, theta z1 is 180. So this is also 180. Both others are zeros. Correct? Right? So theta a1 is what? 540. Okay. 540 means what? 540 means 180. Am I correct? 540 means 180.
yes, sir.
So this is the direction. This is how the root locus will enter into. Whereas if you look at the poles, it will leave from pole. Whereas here, it will enter into zeros. Okay. Similarly, if you do the calculations, theta A2,
Sir,
yes.
but you have drawn with the orange sign, that indicates 0 degree, not 180.
Which one?
From minus 2. 2
No, no,
minus
no.
2.
It is entering from 180.
From, okay, okay.
Yes, from 180. Okay, it is something like this. The root locus will come like this. Okay, if it enters like this, it will be 0. You got it? Okay.
Yes, sir.
Yes,
Yeah.
sir.
So
Yes.
now theta A2 will be 360. Now you have the point. Okay. So that will be like the next one for this one. Okay. So that's how it goes. 360 means what? 360 means it enters like this. You got it? At 0, it will enter. Okay. So ultimately, this will be like this. Okay. Any doubt? Okay. So let me draw the first image again. This one. And now we have every information.
Sir, can you tell me 360 degree? That is pole
360 means 0, no?
zeros. Yes.
Yes, with 0 degree it will enter. What is the 0 degree line?
Yeah. 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 Yeah.
This one only you're asking, no?
Yes, sir. Yes, sir.
What is the 0 degree line with respect to this particular pole? What is the 0 degree line? This is the line.
Yes, sir.
From there it will enter. Okay, from
Yes.
there it will enter. That's the point. Okay, so now let me take that final thing. Okay, so this is what we have. Okay, so now I'll draw the root locus. Okay, so already these points are on the root locus. Okay, so you could see here the 2 points. Okay, so this is already, you can, if you want, you can see that their departures are opposite direction. Am I correct? These departures are opposite direction. Correct? One is 60 and one is the 180 and another is 0. Correct? So they will hit at this point. Okay, one will go like this, another will go like this, the 2 poles. Okay, then here between these two zeros, okay, their arrivals are opposite. Am I correct? The arrivals are opposite. Okay, so these poles, one will come like this, another will come like this, one will go to left, another will go to left, which satisfies. Correct? Okay, any doubt? Any doubt here?
So is there any minimum height or something where we
Sorry, sorry,
can?
sorry.
How will we know that there is minimum height from where we need to bend that curve?
Listen again. I'll tell you. See, this is the picture we have. Correct?
Hmm.
If you go back and see the arrivals and departure angles, okay. So this angle will be like this. This angle will be like this.
Hmm.
Okay. This angle is like this. This angle is like this. Okay.
Hmm.
So here, if you see these two poles, what are they are doing? They are traveling in opposite direction. Okay.
Hmm.
They travel in opposite direction. They will hit at this point. Okay. One will go like this, another will go like this.
Okay.
Okay. So in this direction. Okay. That is first thing. Next, here, if you see uh, the arrivals are, it is arriving like this, it is arriving like this. Okay. In the starting, we said that out of 4 poles, 2 poles will go to 2 zeros. Correct?
So how come this is necessity that the two poles from -1 and 0 will
That you will
arrive
understand.
arrive?
That you will, yeah, that you will understand. Okay. So here you
Mm,
could see this goes like this. Okay. This
mm,
goes like this. They will hit at this point. One will go to left towards 0 at -2. One will go to right. Sorry, one will go to left towards -40. One will go to
yes.
right towards at -20. Okay.
Yes.
So this condition is satisfied. Okay. Then we said
Yes.
that out of four poles, two poles will go to infinity. Correct.
Yes. Yes.
These are two poles, -10 and -5. What they do is they simply start at this -10 and -5. Okay. If you check their angles
Yeah, they are all in same direction.
in this direction, correct? Opposite
Okay.
direction, they also. Okay. So what they do is they are opposite direction. So this five, basically they follow these asymptotes. These are two asymptotes, the green lines. Okay. So
Mm,
we found that sigma is already -5, correct? The centroid.
yes.
So basically this -5, it starts and travel in this direction, departure. The 5 starts in this direction. Okay. So both they do like that, and one pole will go like this, and another pole will go like this towards infinity. Is it clear?
Yes, sir. I got it.
So this is the root locus.
So that's what I'm saying, sir.
Ah,
Sir,
The
yes.
-5 and -10, two poles are
Mm,
going each other towards each other.
yes. No, no.
Uh,
Towards each other means they'll not hit in the middle. If they hit in the middle, they cannot follow these asymptotes. So they will hit at -5 point only because the asymptotes are existing there. Okay. Or else you can also put it like this if you are having doubt. So whatever we draw, these are asymptotes only. Okay. So let us say you are saying like this, correct?
yes, sir.
So you can assume like they are hitting here. Okay. So one
Yes,
will
sir.
go like this, another will go like this. Okay. But here we cannot say like that. Why? Because the five travels in this direction and go back again. No, that won't happen. Okay. So due to that reason, they will hit not in the middle, somewhere here, close to 5. Okay.
Yes, yes.
Yeah. So that's why the 10 will travel close to 5. There they both will hit. Then it goes like this. One will go like this. So
Okay.
mostly this -4, 5 will not move much, but it will take turn there only. Okay. So this is
Okay.
the direction. Wherever we have poles, their k is equal to infinity. Okay. Wherever they have ending, that is k is tending to infinity. Sorry. This is k is equal to 0. K is tending to 0. All pole locations are k is tending to 0. All pole locations where they are ending, their k is tending to infinity. Is this clear? These are the basic steps. You need to draw the root locus. Okay. Any doubts? Okay, let me solve you one more example which you'll understand in a better way.
Excuse
Okay.
me, sir.
Yeah.
From this diagram, we have
Mm,
one pole
mm.
starts at -1 and one pole is 0. Okay? From
Yes.
-1, it will goes to from 0 degree, and from 0 it will go to 180
180.
degree.
Yes,
They
correct.
will they will collide and they will break away. This
Yes,
thing. No?
breakaway. This is the
Huh.
breakaway point.
So how will we come to know that what the point they will break it
That is the question.
from what?
That is extra question.
Oh, So
At
this
what?
is the rough
Yeah,
diagram.
yeah, your question is right. Your question
Yeah.
is you're asking a question on real axis. At what point they are doing this breakaway?
Yeah.
That we can answer.
Okay.
Right
Is
now, I'm
there
sticking
a
myself to the yeah. There is a method.
okay? Okay, sir.
Yes. Similarly, here also the break in that also we can find because they are coming and reaching to that point. So break away, break in. Okay, these two are nice questions. We have to find the answers for that. Okay. In fact, you see my previous lecture, previous live session. I did
Sir,
one problem. Ah,
yes, sir. That is on j omega axis. We have to put s equal to j omega. Then
yes, exactly,
we have to.
exactly. Yeah, that's why. See the previous live session. I've solved one example. There, it will answer these both the questions for that example.
Then sir, if the point is breakup point is in real axis, then what we will put that time
Means.
for breakup point, if
Hmm.
the crossing point is on imaginary axis, then we are putting s equal to j omega, and we
No, no, S
calculate
is
it
equal to
from
J
there.
omega, that is different. S is equal to J omega is the case. Let us say sometimes your root locus will be like this. Your root locus will be somewhere, the root locus, if you have two things, they'll hit here. Okay. One will go like this, another will go like this. Okay.
Yes, sir.
If you are interested to find at what point it is crossing the J omega axis, because it is going from the stable region to unstable region. At
Yes,
that
sir.
case, you will substitute S is equal to J omega.
Yes, sir.
That
Yes, sir.
case is different. That question is different. There you are asking what is the value of K for which the root locus is crossing the J omega axis. That question is different. This question is different. This question is different. Okay. In fact, all these three questions I have answered in the previous live sessions. So please check that. Okay. Now in this session, try to get the clarity on the steps, exact steps and calculations. Let me quickly draw the one more example. You'll understand much better. Okay, so I'll draw it quickly. So second question, g of s equal to s square plus 4 divided by s multiplied s square plus 1. Okay, so now gc of s is the k multiplied s square plus 4 by s multiplied s square plus 1 divided by 1 plus k multiplied s square plus 4 by s multiplied s square plus 1. Okay, so step 1, Evans form. Okay, so this Evans form gives you G2 of S, okay, as S squared plus 4 by S multiplied S squared plus 1. Okay, so Evans form is nothing but what? G1 of S by 1 plus K G2 of S. That is Evans form. Okay, now what are the open loop poles? So P1 is equal to 0, P2 is equal to minus J, P3 equal to plus J, correct? Okay. What are open loop zeros? So Z1 is equal to minus J2, Z2 is equal to plus J2. Am I correct? So now draw these. Okay, where they are existed, can you tell me? So you have pole. Okay, where you have pole at 0, correct? You have another pole at minus J. You have another pole at plus J. You have 0 at this is plus J, correct? Yeah, this is minus J. Okay, plus J2 minus J2. Am I correct? This is pole zero diagram, right? Now, can you tell me anyone about real axis segment? Can anyone tell me real axis segment?
It is just 0.
Uh, the real axis segment would be like this complete thing. Am I correct?
Yes, till the minus
Yes, sir.
infinity.
Yes, sir.
The relaxed segment would be like this. Now, what is the n? N here?
3,
Till 3.
Uh,
3, 3,
3. Okay, what is m?
2.
2. Okay, so what will happen ultimately? Can you tell me? So out of 3 poles, 2 poles will go to 2 zeros, correct? One will go to 0 at infinity. Am I
Root.
correct? Now, can you anyone guess root locus of this one using this? Because this entire thing is on the root locus, correct? Can anyone tell me? So obviously, you can easily say that this pole will travel like this as k is increasing. Am I correct? Yes or no? Am I correct? Okay. The two other poles, obviously, they are going to reach what?
Sir, zeros.
Zeros only. We have 1 0 nearby, we have another 0 nearby. The question is, this pole, it can reach this 0, correct? The question is it reaching like this? Is it reaching like this? Is it reaching like this? That is the question. Am I correct? So obviously this will also, whether it is reaching like this, or reaching like this. Yes or no?
Yes, sir.
Okay. How do you find that?
By
How do you
angle
find?
of departure at plus j.
Yes. Yes. So you will find theta di, you will find theta ai. Okay. For every pole and 0, you will find theta di. So you will find what? Theta d. Let us say this is the P1. The other two are P2 and P3. So theta D2 you'll find, theta D3 you'll find. Okay. Similarly, you'll find theta Z1, theta Z2. Correct? Can anyone tell me what is theta D1? Can anyone tell me theta D1 is? What is theta D1? 180. Yes or no?
180.
180. It is very obvious. It is going towards that. Okay. So based upon that, if you do these calculations, okay, you will see whether your root locus is reaching this pole like this, okay, or it is reaching like this, or it is reaching like this. Am I correct? Okay, so I'm giving you the values. Let us draw it. Okay, I'm giving the values. Okay, theta D1 is minus 180.
Sir, theta d1 is minus 180.
Yeah, so theta D1 is minus 180. Minus 180 and plus 180 both are same, no?
Yes, sir.
Okay, so let's say this is Z1, this is the Z2. Okay, theta D2 is 0. Okay, theta D3 is minus 360. I'm sure you know how to do these calculations. Okay, then theta A1 is 360. This one, theta, these are A1 and A2. A1, A2. This will be 360. And theta A2 will be minus 720. Okay, now tell me. So theta A1, theta D1 minus 180 means what? This is minus 180. Am I correct?
Yes, sir.
This way, this direction, that is minus 180. Correct? So it is going in the direction only. Okay. Yeah, this way. Okay. Now theta D2. How much? Theta d2 is 0
0.
degrees. Now, what do you mean by 0? Theta d2 is nothing but what? Angle with respect to the P2. P2, the root locus is starting with what angle it is getting departure. Correct? What is 0? Tell me here. 0
It's a
means
right
we
side.
have to
So
we
parallel.
have to draw this horizontal line. Okay. Now in this horizontal line, what is 0 angle?
Along what
Still in
x-axis.
a line.
This one is
Yeah.
0. Correct?
Yes, sir.
Yeah. So now we have this theta z1. Okay, that is related to what? Theta a1. Am I correct? What is that angle?
Yes. 360.
360.
360. Again, do the same thing. Okay. What is 360 means?
0 degree.
Yes, 0 degree. So it is entering with this angle. You got it? Entering with 0.
Yes, sir.
What is the root locus now? Tell me. Root locus goes like this. Okay.
Yes, sir.
So here also it will be same thing. Is this clear? This is root locus image. Any queries? Any queries? Any queries? Okay.
No.
So let us quickly try one more problem. I'll give you the values. Okay. So third one. So here let's say g of s is 1 by s cube, s plus 8. Okay. So again, gc of s is so k g of s by 1 plus k g. Okay. So this is your g1. This is your g2. Okay. G2 of s is nothing but 1 by s cube multiplied s plus 8. This is events form. Okay. So what are open loop poles? Can you tell me? So P1 0, P2 0, P3 0, and P4 is minus 8. Am I correct? What are open loop? These are poles. Open loop zeros. What are open loop zeros?
No.
No zero.
No
No
zeros.
zero.
Okay. Now here, what is the M4? What is the M0? Correct? Now, if you draw the pole zero diagram, how does it looks like? What are the poles location? You have 3 poles at 0, correct?
Yes, sir.
And you have another pole at minus 8. Okay, this is the pole zero diagram. There are no zeros. Okay. Now, so tell me the real axis segment is the strip between minus 8 to 0. Is it part of root locus or not?
Yeah, yes, sir.
Yes.
Yes,
Yes.
sir.
Why? Because if you are traveling anywhere on this strip, your right side will be 3 poles only. That is a odd number. Correct? Okay. Next.
Sir, in previous question, we don't have to find that path.
No, no, we have to find it. You have to see. You have to find the asymptotes also.
Then how we will find
That question
this?
I left it to you. Finding sigma and asymptotes, I left it intentionally. You check it and
Okay, sir.
get me the answer. Okay.
Okay, okay, sir.
Yeah. So here now, okay, if you do the calculations, okay, you'll get sigma as -2 here. Okay. And here the alpha will be 0, 1, etc. n minus m minus 1. 4 minus 0 minus 1. That is equal to 3. Alpha is nothing but 0, 1, 2, 3. Correct? Four angles you will get. What is basically phi alpha? What is phi alpha equation? The asymptotic angle.
180 plus
So 180 plus alpha 360
360
by
n
n
minus
minus m. Okay. So where alpha is 0, 1, 2, 3. If you do the calculations, you will get 45, 135, 225, 315. Okay. So sigma you will get as -2. These are the angles. Okay. If you check that, this will be somewhere -2. The angles are, this is 45. Okay. This is minus 135. Sorry, 135. And this is 225. This is 315. Is this clear? All angles are like this only. Is this clear?
Yes, sir.
Yeah. So you have to find these everything. So the arrivals and departures of everything. Okay. Now tell me. So what will happen to these all the things? Can anybody tell me how the truth locus will follow these asymptotes? So obviously you have four poles, four asymptotes. Can you tell me what will happen? So what will happen is this -8, if you do the calculations, you'll get departure angle like this. Okay. It will try to travel in this direction. Okay. Similarly, all these poles, three poles, you'll get departure angle like this. Okay. So out of these three poles, two poles, they will hit at nearby location. Okay. They'll hit at nearby location near the zero. One will go like this, another will follow this asymptote. Okay. There will be another four pole left. Correct? That pole will travel like this, opposite to that -8 pole. They both will hit at this point. Okay. -8 or this pole, it will go like this, and the another pole will go like this. Is it clear?
Sir, here what is the role of centroid? But
The centroid is giving you the location for propagating the asymptotes. It will tell you these are the directions. That's where the asymptotes starts. With respect to that, you will draw the asymptotes. Okay. Once you have the asymptotes, the poles will follow those asymptotes towards infinity. Is it clear? Okay. So obviously you have what? You have one breakaway here, correct? You have another breakaway. Am I correct?
Yes, sir.
Yeah, two breakaway points. So this is how you will draw the root locus if any function is given. So as k tending to 0, and here k is tending to infinity. Pole's location indicates k is tending to 0. So final location indicates k is tending to infinity. Okay. So you take the functions. Oh, okay. We need to go for the surprise test. I forgot it. Okay, are there any quick queries? Are there any quick queries? Okay, solve the examples or exercise problems, anything from any textbook. So if you're unable to get the answers, you can ask me. Okay, so we'll
Sir,
start.
can you give
Yes.
the solution of five week 5, 6, 7
What? The
graded and
No, no,
practice
no.
also?
The thing is that the course administration is that we don't give the solutions of those practice and graded assignments. Okay, so you solve them, and if you are having any doubt with respect to those solutions, you can ask us either through the mail or in the live sessions. That's the course administration. Because most of the people, they are asking for the solutions. So the uh, course administration is that we don't provide the solutions for those. Okay, instead we'll help you to find the solutions. So you solve them. If you stuck somewhere, you can ask us. If you want us to check your solutions, whatever, after you have done the solutions, you can show us for the verification. Okay. Yes. Okay, so take this surprise test. Okay, so g of s is 1 by uh, s square minus 1. Okay, draw the root locus. Okay, draw the root locus and show all these steps. Show all the steps. Okay, here proportional controller you have to use root locus with proportional controller. Okay, so you have about 15 minutes time. Okay, so please finish it and send it to my email. The solutions, take image snapshot and attach to the email.